Okay, this is the backside of chapter 4, 5, and 6, review worksheet D. It's about confidence intervals and sample size problems. So here's some examples. Let's just start with number 5 here on the backside. And it says how many applicants, so right there's a hint, how many would we have to randomly survey to know the percentage? So it's how many to know a percentage. So as soon as you see that, you should look on your formula sheet, and you can see the formula is n is equal to z alpha divided by 2 divided by the error, that whole thing squared, times p hat times q hat. So we want to know the percentage within 1.5%, so that means the error is going to be 0.015. So you got to change that 1.5% into point, you move the decimal place over 2 places, so it's going to be 0.015 with a 90% confidence level. So, we have to tell you the error and the confidence level. P hat and Q hat is not specified in this problem at all, and if it's not specified, then we just make P hat times Q hat equal to 0.25. It says that on your formula sheet, but it's easy to forget that. So if P hat and Q hat are not given, you have to remember that P hat times Q hat you're going to use as 0.25. Okay, so make a note on your formula sheet so you don't forget that. So we have 90% in the middle. So you draw yourself a bell curve and you put 90% in the middle. And that leaves 10% left over. 10% divided by 2 is 0.05 in each tail. So 90% in the middle, 0.05 in each tail. You're going to look that up on the Z table, and it should be circled on your Z table because you use this quite a bit. So you look at your Z table and we look for 0.05, and it should be circled, and it is this asterisk right here, halfway between 0.0505 and 0.0495. So the Z we're going to use, you follow the little arrow down here to the very bottom, and it goes over and it tells you for an area of 0.0500, we're going to use negative 1.645. We don't really care about the negative because we are going to square it and it's going to become positive, but you can put that in there if you want. So it's going to be negative 1.645 divided by 0.015. We're going to square that, and then we're going to multiply the answer by 0.25. So let's see if I can find a calculator, and we'll do that. So I have negative 1.645, and I'm not going to put the negative in there because I'm going to square it, it's going to become positive. 1.645 divided by 0.015, that equals 109.6666. I square that, so this is 109.7. I'm going to square that, and then I'm going to multiply the answer times 0.25. So times 0.25, that gets me 3006.7. So this equals 3006.7. Remember this formula here, you have to always round up. So it's going to be 3007 is going to be the answer. So we'd have to estimate, we'd have to survey 3007 people to make sure that our error for a percentage is less than 1.5% with 90% confidence. So that's number 5 on the review worksheet D. Okay, let's look at the other side now. Let's look at number 6 now. And it says how many rural students, so again it's a how many question, will we have to survey to know their average GPA. So this is how many to know an average. So again, from your formula sheet, this is this formula on the formula sheet, n equals z alpha over 2 times sigma divided by the error, and then the whole thing squared. Okay? So that's the other sample size formula for averages on your formula sheet. Z alpha over 2 times sigma divided by the error. Now, what do we know in this formula? Well, we know we want to be within 0.05 GPA points, so we know the error is going to be 0.05. We want to be 95% confidence, and we're going to assume the rural student population standard deviation is close to Berkeley's claimed overall population standard deviation of 0.32. So it gives us sigma, and of course it has to do that. We don't calculate sigma ourselves. It's got to be given in the problem. So you got to remember that, right? Sigma is, if you need sigma, it's got to be given in the problem. You're never going to calculate sigma. So the only thing we got to figure out is what is the z for a confidence level of 95%. So again, we draw a bell curve. We put 95% in the middle. It's a z. 95% is 5% left over divided by 2. Each tail has half of what's left over, will be 0.250. So each tail will have 0.250 in it. 95% in the middle, 5% left over divided by 2 is 0.0250 in each tail. This should also be circled on your formula sheet. 0.250 works out exactly right here. And when I look over to the edge to get my z, it's 1.9. And then the third number's up at the top, 6. So a z of 1.96. And it's negative, but again, we're going to square it, so I'm not going to put the negative in there. It's just 1.96 times 0.32 divided by 0.05. Push equals, and then square that. So on my calculator, 1.96 times 0.32 divided by 0.05 equals 12.54, and then I have to remember to square that, and I get 157.35, and of course I have to round that up. This is the other formula that you always round up, so it's going to be 158, and that's my answer. Okay, so that's number 6 on the review worksheet D. This is chapter 4, 5, and 6, review worksheet D. Number 7, it says, we randomly surveyed 450 students, and we found that 99 were accepted. So 99 out of the 450 were accepted. Find a 98% confidence interval. So right there it tells you a 98% confidence interval for a rate, for the actual acceptance rate. So you have to remember that rates are percentages. So this is a confidence interval for a percent. So here's the formula. It's p hat plus or minus z alpha over 2 times the square root of p hat times q hat divided by n. So this is on your formula sheet. So step 1 is what's p hat? Well, p hat is x over n, and it is 99 out of 450. So it's going to be 99 divided by 450. You do this on your calculator. 99 divided by 450 is 0.22. And then, of course, that means q hat. If p hat's 0.22, q hat is 1 minus p hat. So 1 minus 0.22 would be 0.78. Okay, so that tells us what p hat and q hat are. We put those into the formula, so it's going to be 0.22 plus or minus z. I don't know yet. But this is going to be the square root of 0.22 times 0.78 divided by n from right here in the formula is 450. So the bottom here is going to be 450. We're going to multiply that, divide by 450, take the square root, then multiply it times z. I don't know what z is, so let's figure that out. We want to find a 98% confidence interval, so I'm going to put 0.98 in the middle. That's 2% left over. So 2% divided by 2 is going to be 1% in each tail. 0.0100 in each tail. So again, we go to our z table, and now we're going to look up 0.0100 in the table. This should be circled on your z table, and it is 0.0099. So the closest to 0.0100 It's between 0,102 and 0,99, so I would go 0,099. Look over to the left is 2.3. Up at the top is 3, so the critical z there is going to be 2.33. So that goes right in here. I'm not going to put the negative because it's plus and minus, so the negative doesn't matter if you're going to add and subtract it. Okay, so now I'm going to multiply the 0.22. Let's do the square root first. So 0.22 times 0.78 divided by 450 is equal to 0.0038. I'm going to take the square root of that, and then I'm going to multiply that times 2.33, and I'm going to put that in memory because I'm going to need it in a minute, is 0.045. So this whole thing here is 0.045. That's this second part of this formula is 0.045. So it's going to be 0.22 plus or minus 0.045, and that'll be our confidence interval. So that'll give us two answers here. So I'm going to do 0.22 plus 0.045, and I put 0.045 in A in my memory so I don't have to type it in again, is going to be 0.265. That's the upper limit. And the lower limit is going to be 0.22 minus A. So I just scroll over here and make that plus into a minus. And that turns out to be 0.175. So it's going to be, the confidence interval is going to be somewhere between 0.175 to 0.265. Remember, this part here in the formula is our error. So our error is about 4.5 percentage points. So that's a pretty big error. You know, we might be able to get it down lower. And up here we wanted an error of 0.015. So to get an error of 0.015, it took us 3,000 in our sample. Here we had 450 in our sample, and we had an error of 4.5%. Okay, last problem, number 8. This is a confidence interval. We got 8 local students' GPAs, and we want to find a 98% confidence interval for the average GPA, the mean GPA. So this is a confidence interval for an average. So here's the formula. It's going to be x bar plus or minus. Now here's a tricky question. There's two formulas, confidence intervals for averages. One has a t in it if you're given S. The other has a z in it if you're given population standard deviation sigma. We don't have population standard deviation in here, so we're going to use the formula confidence interval with the t in it. So it's going to be t alpha over 2 times t alpha over 2 times S, which is the sample standard deviation, and then divided by the square root of our sample size. So with this problem here, you've got to figure out what x bar and S are using your calculator. If you don't know how to do that, come see me and I can show you that. So on my calculator, I clear memory. I'm going to clear out the standard deviation, and then I'm going to put all these numbers into my calculator's memory. So 4, and I always hit M+. You just hit M+ right here on a Casio. 3.6 M+, 3.9 M+, 3.5, 3.8 twice. So I just hit M+ twice, 3.9. And I think that's all. 1, 2, 3, 4, 5, 6, 7, 8. So one more 3.9. There were two 3.9s there at the end. So I hit M+ again. I've got 8 numbers in there. So to get my average, I hit shift and then standard deviation, or statistics variables, and x bar. So x bar is 3.8. And that's from my calculator. I don't know what t is yet. So I'm going to put parentheses. Let me see what S is. I hit shift and statistics variables, and then I hit number 3 for S. Remember, you never use sigma, you always use S. And SX, or S, is 0.169. And then my sample size was 8, so I'm going to divide by the square root of 8. So the only thing you got to figure out here is what is t. So I draw myself a bell curve. We're doing a 98% confidence interval, so I put that in the middle. That's 2% left over. So divide that by 2, that gives me 1% in each tail. I'm going to use a t, which means I got to use the t distribution, the t table. And of course, the t table, you need a degrees of freedom, which is n minus 1. So n minus 1 is 8 minus 1, so degrees of freedom, let me write it right on here, degrees of freedom is going to be 8 minus 1 equals 7. So I've got 0.0100 in the tail and 7 degrees of freedom. I go to my t-table and I look down the left-hand column till I get to 7. Then I look over until I get to 0.01 in one tail. So the area in one tail is 0.01. That's the second column. So 7 degrees of freedom and 0.01 in one tail is 2.998. So my critical T is going to be 2.998. Let me check that again. Yep, 2.998. It's negative, but we put it in the table as positive, or in the formula as positive, because we're going to add and subtract it. So my formula looks like this. I'm going to do this second part of the formula. So the error part I'm going to do first. I've already got standard deviation in my calculator, so I'm just going to go times 2.998 divided by the square root of 8. You can do it all in one step. And then I'm going to put that in memory. So it's 0.179. So my error here is 0.179. So that's the second part of the formula. And that is, this is the error. So I'm accurate to within about 0.18 GPA points. The average GPA for the 8 students was 3.8, so that's this X bar here. The error is 0.179, so I'm going to go 3.8, add that error, and I get 3.98. So that's the right-hand limit, and when I subtract, so all I have to do is go back and make that plus into a minus, I get 3.62. So I'm 98% confident, but the average GPA is somewhere between 3.62 and 3.98. That's a little bit of a sloppy way of saying it. Really what you should say is, if we repeat this over and over again, 98% of the samples will have an average between 3.62 and 3.98. Okay, practice, 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 and email me or text me if you have a question.